Hello everybody, and welcome to VGDA's Unity Crash Course. Today we'll be going over the basics of how to use the Unity game engine, or at least enough so you can get yourself started with making a video game. This video is directed towards our club members who are starting their video game projects, but it'll be useful to anyone who wants to learn Unity, or just needs a refresher on the program. To begin, let me introduce myself. My name is Chung, and I'm one of the two speakers for today's video. I've been in VGA for about 3 years, and I actually learned Unity from this very workshop. Over here is a list of projects that I worked on. The picture above is the very first game that I've helped make, Fadeaway. It's a story-driven platformer on 4 levels. Over at the bottom picture is another game I worked on, Just Another Day, which was a visual novel kind of puzzle game. It was basically a game that I tried to fill as much nonsense into within 24 hours as I could. Um, to summarize, I basically have some with making games with Unity. Now, moving on to our other speaker.
Hello, my name is Culver, and I'll be one of the presenters here who will be teaching you the Unity Crash Course workshop. As of this moment right now in the year 2021, I have roughly 3+ years of Unity experience. Some of my projects include a High Noon Simulator, which was a cowboy-based FPS shooter, Paintrush, which was a local multiplayer Splatoon-like game, Chicken Coop, which was a Starflux-like shooting game or space simulator, and Block Party, which is an untitled up-and-coming project. So first and foremost, before we get into our Unity Crash Course workshop, what exactly is game development? Well, what exactly is a game developer in that sense then? And a game developer is just somebody who makes video games. That can be an artist, a programmer, a designer, or anyone who directly participates in the art or the craft of making video games. Now, a game developer is not an idea guy. A game developer isn't someone who comes up with these cool concepts and mechanics and can't implement them, or who comes up with these good ideas and has nothing to show for it. Anyone can come up with good ideas, but it takes a true developer or someone who is skilled to actually bring those passions to life. And that's what we try to do here at VGDA. And the goal of our club is to get each and one of you to become a game developer. And a good game developer is a generalist, which means that there will be a spilling of skill sets that go into your main skill set or your main specialty. So artists will, in some aspects, learn to program, and programmers will also learn some art along the way. That's what most good game developers are. They're generalists of sorts, while having one specialty, but also knowing a little bit about each discipline to make it worth their while. So let's look more into that. Here we have the game developer growth tree, and this shows the four main paths of game development and their disciplines. From left to right, we have sound, engineering, design, and art. And as you notice, as these arrows pass and these colors kind of melt together with one another, there are some instances in certain disciplines where you need to know a little bit about both. From left to right, we have audio design, which goes from basic sound design and encompasses some levels of engineering, which eventually to audio engineering, which looks to be more engineering than sound at some aspects. From our engineering to design standpoint, we do have Unity scripting, which kind of feeds into gameplay design and mechanics design. There's a lot of blurring in between the paths as to what exactly each person can do or which skill sets might be necessary for each department in game development. And that's what I think is really fascinating, really interesting, how it requires multiple skill sets, multiple disciplines, not just one good specialty. And that's something I really appreciate. And I hope throughout everyone's time at VGJ that you learn to pick up something that's perhaps out of your specialty or out of your comfort zone in hopes of becoming a better game developer. So what does that mean? How do we know how to get better at game development? Well, the first step is to try. So good job on you for coming to this workshop and attempting to become a better game developer. Here at Cal State Long Beach, we like to use Unity. It is our game engine of choice. We use that a lot in VGGA. It's easy to use, easy to learn. It's free. You can download it here. And there are plenty of online tutorials and resources. Um, a lot of people ask us why we tend to use Unity more so than other engines, and it's a very simple and easy to understand reason. There's just a lot more online resources to use for Unity, and there's a large open community for resources regarding that engine. That is not to say we don't support other engine uses such as Godot, Construct 3, Unreal Engine 4. It's just Unity is something that we're very comfortable with teaching, and that kind of goes in tandem with our Cal State Long Beach computer science curriculum. Our Cal State Long Beach computer science curriculum is very Java centric and Java based. So we actually so it's very centered on Java-oriented programming and to some aspects C Sharp. And Java and C Sharp are very closely related, and C Sharp just so happens to be the scripting language that Unity utilizes. So with that in mind, I actually see Unity as a very good support system to understanding certain programming aspects of uh, computer science when coming in tandem with our courses. And I feel like it very strongly relates to what you're learning in class, and it could very well be useful to our programmers in our club. So that's the main reason why we use Unity. It's easy, it goes along with our curriculum, and most importantly, it's got great online resources, and it's free. So this is why we use this specific toolset.
Usually when we do our Unity Crash Course workshop in person at our club, we show our participants this video made by the YouTube channel Extra Credits, and we'd like for you guys to check it out as well. The video is called Making Your First Game Basics, How to Start Your Game Development, and it's a great video for understanding how to go about learning how to develop games and what to expect when you create your game projects. So if you could, we'd like you to pause this video, go check out their video, link in the description, and then come back. Alright? Alright.
Okay, so after that video, we can all agree it is very difficult to start off your game development journey. Before we get started on the workshop, I want you guys to know that it's okay to not understand what's going on. Justin and I are very much here to help you and walk you through this situation. You have the whole VGA Discord to ask questions and get involved and get helped out in our community, and I highly encourage that. Yeah, I understand it can be very difficult to start your game dev journey, and I want you guys all to know that it's okay, just keep moving forward. And with that being said, let's get into the meat and potatoes of what exactly we're doing today. Today we'll be making our first Unity project. We're going to be following a few exercises to learn about the Unity interface, the objects and components, scripting concepts, and using asset packs. If you don't know what any of that means, that's totally okay. That's what this video is for, bud. So without further ado, let's get it going.
Right, to start off, we're gonna first install Unity. Right now I'm in the Unity download site. You can get here using this link, which will be in the description, or you can just type in download Unity, and this is the should be the first place that it brings you to. And so over here we have to choose a Unity version and download, or we can download Unity Hub. I recommend downloading Unity Hub, and I'll do so, and I'll explain why in a moment. We'll just install that. If you get an error with the installation process, you can always try and download a specific version of Unity. But if you can't, I recommend installing Unity Hub. And so you agree to the terms of service, place to install, and we're gonna install it. There we go. We're gonna finish up, and now we're gonna open up Unity Hub. Right, so when you open up Unity Hub, you should see something like this. If you don't, you should see something similar. And the reason for that is when you first install Unity Hub, it should take you to over here, preferences, which you get to by clicking on this little cog here. And the reason for that is because we don't have a license. And so Unity takes us to this specific page first so we can activate a new license. This doesn't cost anything, so first you want to click activate new license, click on Unity Personal, and then click I don't use Unity for in a professional capacity. We're just gonna use this for our own personal projects. So after we click done, that should generate a new license. Great. And so to get back to the page I was earlier, we just click on this here, and it should take us back to the projects page. Now here, it shows a saved list of all our projects that you've worked on. For to most people, this should be empty because you just installed Unity and you wouldn't have all these projects like I do. Alright, so at the other tabs of Unity Hub, we have the Learn section. This is a bunch of projects that Unity has for beginners, which you can take a look at, but right now we're doing our workshop. There's also Unity Community. This, I believe, takes you to certain sections of their website that you might be interested in. But the main important one is installations. Here, installs, it shows all the different versions of Unity you have installed. Right now, you shouldn't see any. That's because when you first install Unity Hub, you're not actually installing Unity. You're installing a manager that handles all your different installation versions of Unity. And the reason for that is because when you start projects, sometimes you're going to have projects with different versions. Like let's say I have this project that I worked on a few days ago, and it's probably going to have a different version than a project that I maybe started a year ago or I last worked on a year ago. And so it's nice to first Unity Hub tells you what version this project is on or was last opened with. And it also holds all your versions together, so in case you want to go back to your older projects. So now what we want to do is install a version of Unity. So over here we're going to click Add, and I recommend installing the latest official release of Unity. So for as of this day, it would be Unity 2020.2.2 F1. So we're going to click on here, and we're going to click on Next. And now we're going to see a bunch of little add-ons that you can add to your project, depending on what you want to do for your game that you're going to work on. You might want some of these packages in the future, but for right now, what we want is Microsoft Visual Studios Community 2019. So make sure you install this for your first version of Unity that you install, and for the rest of them, you don't need to install it. So I already have Visual Studios, so I'm not going to click on that, but make sure that you do, and we're going to click Done. And it's gonna ask me, yes, I want that to make changes, and it should be installing now. And what Visual Studio is, it's an IDE for programming and C Sharp, which is what Unity use. Um, what is an IDE? Um, actually, I forget the abbreviation. Give me one. Alright, so now that we have Unity installed, we can go ahead and create our project. So we're gonna go to projects. We're going to click on new, and then we're going to click on the version of Unity that we just installed. And that's going to bring us to this page. And from what you see here, the first thing you want to look at is templates. Over here is the different kind of Unity projects we can make. Um, don't worry about most of these. The two you want to focus on is 2D and 3D. Starting out, these are the two projects you're going to work with. For this specific workshop, we're going to work with Unity 2D, and that's because we're going to work with 2D assets later on in the workshop. Over here, um, we're going to name our project. So I'm going to name mine Unity Crash Course. You can name yours whatever you want. And then over here, you want to have a location where you want to keep your project. I'm fine with this location, so this is fine. And make sure you click on 2D before you click create, because if you accidentally have it on 3D, your project's gonna look way different than mine's, and you're gonna have to restart it because there's no way to convert between after a project's already been made. So then after all that's set up, click create, and that's gonna start loading up Unity. And this is actually gonna take a while, so I'm just gonna cut to when the installation is complete. Alright, so then your Unity project is gonna start loading up. And after it's done loading, it's gonna pop up a screen like this. This is our project, and don't worry about all these tabs everywhere, and or if your tabs look different than mine. We'll get into that in a second. First things first, you want to go over to here, click on edit, drag down, go down here, go to preferences, and then on general you want to go over here at editor theme. Right now it's at light, you want to click on dark. There, that's better.
Hello everyone, good afternoon, and welcome to the Unity Workshop course. I will be one of your instructors, Chloe, and without further ado, let's jump into the Unity interface. So first and foremost, let's talk about what exactly we're seeing here. There's a lot of different panels going on here, so let's talk about them. Our first one, and probably our most important one, is the one we have right in front of our eyes. It's this big block that appears. This is our scene view. It is indicated by the blue little line above this tab, and the scene view essentially shows us everything in our game world. If we look to our left, we have something called our hierarchy tab. And if I click that, you see the blue line again, just letting you know what tab you are on. And the hierarchy tab actually gives us a list view of all the things in our scene. So what does that mean? So let's figure out what scene we're in first. If I look here, I see we are in something called sample scene, and I can only assume that is the scene we are currently in. So if I go ahead and click that, that just shows me what scene I'm in. I can open this list, I can close it. But let's see what happens when I click this object in our list. So far, we see in our scene view, we have something in here that looks like a camera. And if I look to the left towards my hierarchy and I click it, I see it is a camera. In fact, it is our main camera and it is something in our scene. Also, what I've noticed is our other panel on the right, our inspector, gave us more information. And this is exactly what our inspector does. Oops, I clicked out of it. But our inspector basically tells us more about whatever object we're clicking on. So you see, as soon as I misclicked, the inspector went black to blank again. So let's go ahead and click main camera and see what's going on. So again, in our inspector view, we can see a couple more details about the object that is in our scene. It's very helpful. You'll be using this a lot. So make sure you feel comfortable with looking at the objects in this inspector view. Directly below our scene view, we have a couple more tabs. We have our projects tab, an animation tab, and a console tab. Let's go through them one by one. Our project tab gives us a file view or a file version of everything inside of our game. This includes our scenes, it can include our packages that we might have, everything in between. You will see this file or this project tab populate the more you get into your game development experience. This is where we'll be adding, dropping files, manipulating files, organizing files, all that jazz. And if that sounds a little overwhelming to you, don't worry. It's very similar to how our Windows file system works, if that helps you think of it in a better light. Next, our animation tab. This is where we can go about handling animations. We will get into this later on throughout the tutorial, but for now, just know that this is here. And next we have our console view. This is my favorite view as a programmer. The console view actually gives us the chance to write debug statements or little print lines for new programmers out there that just tell us what's going on in our code, as well as any errors we'll have. As I see right here, I do have an error. I'm not sure what that is. Failed to create device file. That's unfortunate, but I'm just going to press clear and we're not going to worry about that. Don't worry about seeing those lines. You get used to it. There are different types of debug lines that we will get into as we move forward into the course. But for now, just know that the console tab is how we interact with the program or our coding in Unity. And for those of you that might be concerned over having a slightly different view, like let's say someone didn't have their animations tab and I just happened to do so, how could we go about adding more tabs? Well, if you look on the far right of most of these tab buttons, I like to think of it as a Google Chrome type deal. The settings buttons on the top or the top right of all these views, they have a menu system where we can add tab, and from here we can add any type of tab that we feel is necessary. So I can go ahead and add another project tab if I need to, and look, I have two project scenes. I can add or even close an animation tab. To close a tab, you right click and you just click close tab. It's that easy. And yeah, that basically encompasses our interface so far as to working into the context of this tutorial. We do have a couple of options in the top left that we will get into as we dive in deeper, but for now, I would like you guys to know about your scene view, our inspector, the hierarchy, the project, and the console tab. And yeah, that basically encompasses the Unity interface. All right, everyone. Now that we know a little bit more about our Unity systems, let's actually get started in the tutorial and start creating something. So now I'm going to show you guys how to create your own game object. And to create your own game object is very simple. But first, let's ask ourselves, what is a game object? A game object is quite literally an object in our game. Enough said about that, so let's get into it. If I want to add an object to my scene, how could I go about doing it? Well, I would go to the left on my hierarchy tab. Remember, this holds a list of all the game objects in our scene. So this is where we'd want to go. And there's actually a little plus sign right here that I can click, and it gives me a whole bunch of options. I would like to select the first one, which is create empty. And here I have my game object. Now let me go ahead and delete this because there's actually another way of adding objects to your scene. I'm going to, again, just right click and delete. And now I'm going to, with my hierarchy still selected, I'm going to right click anywhere in this empty space. A new pop-up will appear that's just asking for more options to do. I want to select create empty out of these options, and it still gives me an object, a cool game object. So those are the two ways of adding a game object into Unity. And as we see, my game object is selected, and I see it in my inspector. It says game object, and it has something called a transform. And a transform is just a component in Unity that gives it a position, rotation, and scale. This brings me to our next topic as to what is a component. A component is just it's like something you add onto the game object for functionality, and transform would be one of them for create empty game object. And I can give you a better example of this. I want to right click in my hierarchy. I'm going to add a new game object. And I'm going to go down to where it says 2D object, and I'm just going to click sprite. I see I have something called new sprite. And if I look in my hierarchy, I see it has two extra components compared to that of my game object, right? If I click through them very fast, I see my game object only has one component, which is a transform, and my sprite has something called a sprite renderer and another material for sprites, and that's really interesting. So basically, the only thing that really separates my empty game object from my new sprite are these two extra components for my sprite renderer. And that's basically what a component does. It just adds on extra functionality to an object. Now, if I wanted to make a sprite from scratch, I see that all that's separating my empty game object from my new sprite that I've just made is just that sprite renderer and a material for it. So let's say I want my game object to look exactly like that, or I want to create this object from scratch. All I need to do is add that component for functionality. So I'm going to look up sprite. I clicked add component. This pop-up menu appears, and I'm just going to look up sprite. I see my sprite renderer. I'm going to click it, and look at that. Not only does the sprite renderer appear, but the default material as well. And all a sprite renderer is, again, is just a component that shows us a picture. It's part of the component system that Unity uses, and it's very useful and it's very helpful to think about game objects in such of a way. A game object is literally just multiple components in a scene. that have different functionalities to it. And that basically describes the component system of Unity as well as how to add new objects into your game scene. So now we found a way to add a sprite render onto our player. We can now see him in our world, or we can see him in our scene. Let's go ahead and check the game tab to see what he looks like. Wonderful, just as expected, if not better. So we have our player in our world. So we have almost half of our tutorial done with. We've created our player with zero functionality. Now we need to add our level. This is a 2D platformer, so we need some platforms to jump onto. So now let's talk about creating our level designs. And first, to start off, let's think about this. What exactly makes a platform in the context of a 2D game? Right? Really, if you take away any movement the player has, this game object that we've made our player can also be used as a platform as well. And what I mean by that is we can duplicate this object for other intended purposes and alter it slightly. So let's go ahead and do that. I'm going to go into my hierarchy. I'm going to go ahead and click my game object, and I'm going to press Control D. Now you notice I just duplicated my object and they're exactly the same, with the only difference being one of them is identified as a duplicate with the number on the side. You see in my scene nothing really looks like it's changed, but that's just because the way Unity duplicates objects, it's quite literally right on top of one another. So go ahead and go ahead and click on your player, or what you perceive your player to be, and move him or her out of the way and bring the other block down. To move objects, it's just a click and drag sequence. And now furthermore, we're going to manipulate this platform that we've made, right? So far it looks really no different than our player we've just created. So let's manipulate its size and maybe lengthen it out. So to do that, Unity gives us multiple tools to actually manipulate objects in our game scene. The current one that is selected for me now is called the Rect tool, and it's used mostly for 2D landscapes or 2D projects. The Rect tool does exactly what you would think. It changes the rectangle transform of a sprite, and it comes in handy. So I'm just grabbing on these little nodes or the edges of this cube, and I'm just manipulating it, moving it around to whoever and wherever I'd like. Other movement tools that come in would be the uh, what's the word? The R keyboard shortcut, which actually gives you the option to scale your object as I was doing with the rectangle tool. If I go ahead and press E on my keyboard, this gives me the rotation function to actually rotate my things. I can just press Control Z to undo that. And if I go ahead and press my W, this gives me the movement tool in my space, where I can move my object up and down the XY axis, or even both by pressing this rectangle to move my objects. Yes. So this essentially will act as our platform. This is exactly what we want. All we did was duplicate our player object and expand upon it by changing its size and moving it out of the way. So now I encourage you all to feel free to go ahead and keep duplicating platforms and make something unique. Make your own platformer. And when you're done with that, come meet back and we'll talk about adding more onto our game level. So for now, everyone take a moment to go ahead and construct their game. Welcome back everyone from creating your levels. Here I am in my game view just basking in my glory at my wonderful 2D level. If I go ahead and look at my scene view, it's nothing quite extraordinary, but it's mine, so I like it. I just made a couple more platforms around my player. I changed their color with the component tool. Not the component tool, the component functionality for the sprite render. It's just very simple. And click and drag this. And yeah, so now we have our level, and that's wonderful. Now let's actually add some game logic into this. And how can we go about doing that? Well, first things first, let's think about what kind of functionality we need to add. What are the aspects of a platform, right? Oh, quick thing before I do this, this is for organization purposes. Notice in my hierarchy on the left, I'll go ahead and highlight it. I have all these game objects with no name, and that can be very confusing. How would I with my own eyes be able to know which one of these is the player? So let's go ahead and change that. I'm going to go ahead and select my player in my game scene, and I'm going to go in my inspector, and I'm just going to click the name up top, and I'm going to write player. And from there, now I know that that is my player. And if I really wanted to, I can do the same thing with the other options. Here, I'm going to go ahead and click F2 just because that's what I'm used to. This is also just another way to rename your objects in your scene. I'm going to go ahead and call this bottom platform and then right platform. I spelled platform wrong, but I'm going to leave it because I'm too prideful. My left platform, and then my top platform. Again, this is more for organization purposes, so you get used to keeping your hierarchy in check, or at the very least readable. The last thing you want is a bunch of empty, no-name game objects that you don't know what to do with, because that makes the process all the more frustrating. Moving on, again, now let's add functionality into our game world. So how can we go about doing that? Well, let's think. What makes these objects move around in this world? Obviously, movement and a couple of other features in Unity that gives us the tools to actually make this happen. So let's talk about it. First things first, for our player, we're going to need something called a rigid body. Rigid body 2D. So let me back up. I selected my player in my hierarchy. I went to the add component button and I looked up something called rigid, or Rigi for short. And I see I have two options, rigid body and rigid body 2D. Given we're in a 2D space, I'm going to go ahead and select rigid body 2D. And all this information comes up. For now, don't worry about it too much. Just know that a rigid body in its bare form just allows physics to act upon our object. It's fantastic. It's a very useful tool. And on top of our rigid body, we're going to add something called a collider. Now, a lot of colliders come up in our search bar when we look up collider. For now, I want you to pick the box collider 2D because our character is box shaped and we are in a 2D setting. So with those clicked, we now have a component that gives physics onto our body, and now we have a collider that actually allows us to interact with objects in the world. So if I go ahead and click play, let's see what happens. This is how we can go about testing our game. So moving into our game scene tab, I'm going to go ahead and click the play button on the top. And we're going to see what happens. And lo and behold, physics has acted upon our object, but it fell right through our platform. This is because we have not added the same functionality onto our platforms. Now, for our platforms, given that we've added a rigid body and a box collider and knowing what those two do, which ones do you guys think will be needed for our platformer? There's only one of those we need. Rigid body or box collider. Remember, rigid body adds physics. A collider allows objects to touch you. I'll give you my little Dora moment. Okay. I've kept you waiting long enough. It's actually a collider. Yes, you've guessed it. A collider allows us to, again, interact with objects physically. So with that box collider added to my bottom platform, I'm going to go ahead and just Control S to save because I haven't done it in a while. Please save your project. And now I'm going to go ahead and press play and let's see what's happening. Look at that. My player has collided with my platform through its rigid body motion, and now due to the box collider components, they are no longer passing each other by. They are in fact colliding, and this is wonderful news. Now that we have some form of quote unquote movement to our player and some sort of game logic, we're one step closer to creating our 2D platformer. Hello everyone. Um, okay. let's jump back into it. Last off, when we started, we added a lot of functionality onto the player and the platforms. And what I mean by that is we've actually given these components to actually have game logic running on them. Not anything intense, but enough to make the rules of our game work and more apparent. Remember, the goal of this was to make a 2D platformer, and for a 2D platformer, you need movement and things to jump on. And as of this moment in time, we have now enabled our environment for us to do that. We have added what's called a box collider onto our platformer, which allows us to actually interact with that object physically. And we've added a rigid body. We added a rigid body 2D and a box collider 2D onto our player to allow them to interact with the world around them by touching objects and also have physics acted upon them. So with those two forces combined, we can actually work to add more functionality into our player and actually get it to move. But how could we go about doing that? Well, as mentioned before, has a really cool entity component system, meaning we can add on functionality by adding a component onto our object. So in this sense, it'd be no different than trying to add a move component onto our player. So how would we go about doing that? Well, we could type in move in the add component, but as we see, there is no generic move script handled in Unity, so we'll have to make our own. And this is where we actually get introduced to our scripting portion of the course, where we'll learn how to interact with Unity through uh, its scripting methods to make things happen or run game logic, specialized game logic for our game. In this case, it'll be movement. So without further ado, let's jump into that. Let me get out of this window and let's meet up in the projects tab. I have that highlighted and I want to make a new folder. I want to make a new folder for my scripts. Remember, to add a new folder, you right click, go to create, select new folder. And I want to name this folder scripts because scripts are very common in creating games. In case you haven't noticed, it's very programming related. So let's just save ourselves the trouble and have a folder dedicated to scripts that we can keep coming back to in reference. And so I have my scripts folder opened. I'm going to go ahead and right click and create a new script. In this script, I want to call it player movement. Now, something very important that I want all of you to know, as I'm typing out this name, there are no spaces within my script name. There cannot be any spaces in the naming conventions of your script. So if for example, I have named my script player movement as one word, and I encourage you to do so as well. Just a heads up, we've had problems with that in the past, so I feel like it'd be better to have a more concrete lesson. Go ahead and write the name of your script single word. So with that, I'll go ahead and press enter, finalize my script, and I'm going to go ahead and open it up and reload it. So welcome everyone. We are now inside our Microsoft Visual Studio compiler to help us script in Unity. I understand this might be very new for some of us to look at, but bear with me. We're going to get through this as smoothly as possible, and I will do my best to explain as much to you as I can about what exactly we'll be doing in here as of now. So first things first, the main thing we want to be concerned with as of right now, so far as getting our player to move, is this public class called player movement. This is actually the script you've just made, and for new programmers, this might be a little interesting to see. You have two functions in here called start and update. So what exactly do those do? If we read the comments above them, we know that start is called before the first frame and update is called once per frame. So what does that mean? Well, we know games run on frames or have a refresh rate known as their frames. So with that being said and us knowing that knowledge, we know start is called before the first frame, so it start before the game actually begins for the player. And we know that update is called continuously while the game is running for that player. So with that being said and knowing what knowledge we have now, we now have a better idea of how to use these functions. Obviously, start would be used to initiate any variables we'll have for the player or anything else we need at the start of our game. and update can be used to obviously update certain informations we want to give out to our game, such as movement. So let's get into that. First things first, what we want to do is we want to make a public variable. I'll make it a public float, and I will call that move speed. This is the variable at which as to how fast we'll be moving our object. How fast will, how fast we will move this object. Fantastic. So now we're going to go ahead and go to our void update, and we're actually going to write a line of code that's going to help us move. And I will do my best to go through each line with you. It's going to go something like this. I'm going to say transform dot position plus equals new vector 3 parenthesis move speed comma 0 0 dot parentheses times input dot get axis horizontal. This is actually very important because it's a string. Make sure it's written exactly how I have mine written, and I will do my best to zoom in for you on that. Yes, please make sure horizontal is spelled the correct way. And we're going to stop right here at this moment. So what the heck did we just write? This looks very confusing. So let's talk about each line or each segment of this line of code, and hopefully I'll shed some light on this. Our transform dot position, if we remember what our transform is, we can actually hover over it. And it will tell us a little bit more about it in the Visual Studio. So if I hover over my transform, I know that this is my transform component that is attached to my object. Unity knows it's there, so it's going to let me access it as a variable to my game object because it is a component, and I keep a list of components that I have on me. Or if not, I can easily attain that component. So basically what this means is I'm getting my own position in the world, my block's position in the world, and I'm plus equaling that to a new vector. Now, a vector, all it is just like a list of 3 floats. That's basically it. It is an array of 3 floats that actually coordinate to world space positions at times. So think of the new vector. Actually, if I hover over it, you can read it. Creates a new vector given x, y, z components. It will hold 3 floats of float x, float y, and float z. They don't necessarily have to be used for movement in a 3D space, but that's primarily what they're used for, and I would like you guys to think of that. So what does this mean? What does this whole line mean right here? We're asking for our own position, and we're adding on to it this movement speed from this new vector we've had. Vectors are how you're normally going to go about moving objects, whether in a 2D or 3D space. So keep that in mind. So really, all this is we're getting our position, and we're adding on this new vector move speed. Now, what's this line at the end right here? We're multiplying by this input.getAxis horizontal. Input.getAxis horizontal is actually just a shorthand or a Unity variable of sorts for getting your arrow key movements and your WASD movements. Unity has its own pre-built library of sorts of certain key commands and key codes that are very useful when rapidly developing stuff. So that's just something we're using. This is basically, again, shorthand for arrow keys. Input.getAxis horizontal. So input is an interface system for inputs in Unity. Get axis, I'm just returning a virtual axis to my keyboard configurations and my layout. And horizontal is just specifying what part of WAS do I want, or my arrow keys, what I want, which is my left and right arrow keys. So this whole line of code basically means find my position in the world, or have my position, and I want to add on to it my move speed times my horizontal input. And we're actually going to see what happens when we do that right now. There is one more thing that we need to add to our line of code though, and it's actually very important. Remember, update is called once per frame, which means Unity will call it exactly once per frame, obviously. But we all know all computers aren't created equally, and sometimes games have really bad FPS, and sometimes games games don't configure their update system to account for it. But here we will. At the very end of this line of code that we made, right outside the parentheses for horizontal, we're going to say times time dot delta time. Oops, I wrote two semicolons. But all time dot delta time means is that in a way it constricts how many times this movement is called in this update system. So basically, it's just a fancy way of saying we lock the number of times this function is called in hopes for a more smoother, easier movement. Because if we left this code as is without the time dot delta time, this function would be called quite more frequently, or this line would be called way more frequently if you had better frames than if you were to have weaker frames. And that just leads to issues down the line when you have different players running on different systems. So for movement, we really do want to take into account adding time.delta time at the end. That's pretty much it. So again, this whole line of code, we're just grabbing our position and we're adding that to our move speed times whatever keyboard input we're getting back. So with that being said, let's go ahead and save this script and let's head back into Unity. Okie dokie. So we're back inside our Unity and editor after scripting, and let's take a look at what we have. First things first, I always like to check the Unity console and see if there are any errors that pop up. More often than not, they 100% will right after scripting because that's where Unity refreshes its scripts and recompiles itself to figure out if there's anything wrong before you hit play. And as we can see, nothing wrong in my console. I'm looking pretty good. Let me go ahead and take a look at my player. Fantastic. Ooh, I forgot to add on the script. So there's actually two ways of doing that. To add on our script onto our player to actually, make it move, you can either click add component at the bottom and search up player movement or player, and you'll find the player movement script. An easier way of doing that is to just navigate to your folder in your projects tab. Go and go to your scripts, make sure your player is selected so the inspector will have it, and we're just going to click and drag it over in the inspector. And that's another way of adding, a script or a component onto your game object. So now we have that insights. There's only one thing left to do. We need to change this movement speed to an actual number. Because if you guys can recall from the line of code that we made, we're multiplying by a lot of different variables. And if we multiply by 0, the whole thing's going to be 0. And we won't actually be able to see our guy move. So I'm going to go ahead and put in a movement speed of 2. I like to set the number just a little bit low. Again, it's for debugging purposes, but now that we have that number into our component, it looks really good, or our whole thing's looking pretty good. Let's go ahead, navigate to our game tab, and play our game. Let's see what happens. All right, so now I'm in the world, and I'm going to go ahead and press my A key and my D key, and look at that. We have some really good movement. Just for the heck of it, I'm gonna go ahead and use my right arrow and my left arrow. And yep, that's functioning as well. Again, these were the A and D keys as well as the left and right key were are what's the word? They are understood by Unity to be hotkeys or very important keys that a lot of developers use. So they've made it easier on us to have their own special key functions that we can call, such as get axis, parentheses, horizontal. That's what it means. But yeah, we have wonderful movement in our world and we're looking really good. Only thing now we're missing is our jump. So with that being said, let's go ahead and jump into our jump function. So now we are back inside of our Visual Studio Code. We are now scripting. Um, I had stopped playing the game preview and we're now back into our code to add a jump feature. So let's get into that. In order to add our jump feature, we tend to treat jumping like a physics, which is why we added on that rigid body 2D. Well, one of the reasons. So we need a way to go ahead and reference that component to actually talk to it and introduce physics onto our object. So let's go ahead and do that. Right under our public float that we made for move speed, I'm going to go ahead and make a private rigid body 2D. I'm going to nickname it RB, and we're going to leave it like that for now. So we have our private rigid body, um, and we want to access it in some way. Unfortunately, we've named our rigid body private, which means it will not show up in the inspector. So how can we go about initializing this variable? Well, that's actually where void start comes in. As mentioned earlier, it's called before the first frame, so it can actually come in handy for initializing variables or doing things you only need to do once to get stuff done. So without further ado, let's actually initialize or assign this rigid body value. I'm just going to type in the name of the variable, which I have named RB. Click equals, and then I want to look for something called get component, right? I'm going to add get component. These little arrows, and I want to look up rigid body, if I can spell it correctly. Rigid body 2D, perfect. Parenthesis, parenthesis, and then semicolon. What this line basically means, it's saying, hey, this rigid body variable, I want to assign that to a component that I should have called rigid body 2D. That's basically it. That's essentially how get component works. I'm just asking for it because I'm near certain that it is on my person and I would like to utilize this component that is attached to my game object. So now that we have a reference to our rigid body, let's actually do something with it. And to do something with that, to constantly update a function or to constantly update the system to let us know that we're jumping and we should be acting upon that force, we are going to use void update. So we're actually going to use an if statement for this one. We want to say if input dot get button down, parenthesis, quotation, jump, and then we're gonna add some brackets to this if statement. Now, what that if statement that we just wrote is asking, it's just saying, did we press the jump button? In which case, jump is also another keyword that Unity has saved for us to mean a specific keyboard stroke or whatnot, and that's basically our spacebar that we have. Spacebar has normally been used for jump, and Unity has been gracious enough to make that simpler on us to access that jump with just a simple string. So here we're asking, I'll write a little comment on it. We're just asking, did we press the spacebar? And if so, we're going to do something. If though. If so, we want to do something. And what is that something? We want to quite literally add force onto our object to make it jump. So how can we go about doing that? Well, we're going to reference our rigid body that we have. We're going to say RB dot add force. And add force is going to ask you for a vector of sorts for your force. Where in what direction and how much of it do you want to apply? So I want to say vector 2 parenthesis nothing on my x-axis, because my x-axis is how I move from left to right. If I'm jumping, I want to go up, which means my y. So I can go ahead and give this a value of, let's say 200 for myself. Vector 2, what's wrong with my vector 2? I need to say new in front of it. There we go. Don't forget to say new in front of your vectors. To put this in perspective, if anyone has used Java, it's very similar to how you would go about instantiating data structures. Vector 2 is just another thing like that. For those of you that don't know Java, just know this is more often than not how we instantialize data structures, or basically how we say, hey, this is a data structure I want to use. If you don't know what a data structure is, feel free to reach out and shoot me a DM or just ask inside of our community Discord. I'm sure we have a whole bunch of programmers that would love to help you understand those concepts. So we have our rigid body. We want to add force to it. That is a new vector 2, our x-axis being 0 and our y being a pretty hefty number. And we're just going to put a semicolon on it. We're going to go ahead and save this. And we're going to jump back into Unity and see how this code compiles. So now I'm back in Unity. I'm going to go ahead and check my console. There aren't any errors yet, thankfully, which means I'm doing everything right. Um, and let's test the code and see how it goes. Okay, I know I can still move left to right, so that's good. We didn't break anything. Go ahead and press the spacebar, and we have a cute little jump going on. Yes, we are actually able to jump inside of our world and get things going. If you are not able to see your jump, most likely what's happening is that your jump power has been set too low, in which case we can fix that very quickly. I will meet you back inside the Unity scripts. Don't forget to turn off play mode before you go back into your scripting and try to change something. Unity always kind of needs a minute to recompile or refresh its code base after you've altered it. So one moment, please. I'll meet you back in Visual Studio and we'll help you debug that. So we are now back into Visual Studio and we're going to debug, or I'm going to show you guys a little bit about how to go about debugging some issues and just some good coding conventions. So on line 28, where we had our rigid body add force, some of you might be experiencing some issues because either this number right here is too high or too low. And we're going to fix that by making it a new variable. So I'm going to go in between my lines of public float, my move speed, and my rigid body. I'm going to go ahead and make another public float, and I'm going to name it jump force. Really easy. I'm going to go ahead and save that. And on my line where I'm adding my force, I want to change that 200 that I put to my jump force. I'm going to go ahead and save that, compile it, and head back into Unity.
Alright guys, I'll be going over the next part for this tutorial. Most of my settings should be the same from Chloe. I've messed with the colors to have them different, and the platform orientation is also different, but for the most part, um, everything component-wise and script-wise should be the same as where Chloe has left off. And actually, from what we left off, um, you guys should have finished everything over that we've needed to do for the player movement script. And last thing we did was add the jump force variable, which is now added, but right now it is currently 0. And we want to change that, because if we click play, and then we try to make our player jump, it can't jump because jump force is 0. It doesn't have any boost to it. So let's say, what if we made this, say, 10? If we try that number, um, it doesn't look like anything is happening, but maybe if we add another 0 to that, make it 100, and we try that, and there we go. We can see like a very small jump from our player. However, I believe that jump is too small to reach from this platform to the other platform. So let's maybe increase that a little bit. Maybe let's say 300 over there. Okay, that's pretty high, but it's not close enough. Maybe 500. Test that out, and yeah, from here you can jump. I can jump over from this platform to that platform. This works out for this layout I have over here. Oh, for the most part. Um, so this number is okay with me. You can mess around with your variables, with your move speed and jump force to mess around to see if these numbers are okay with you. Now, one thing to note is to notice right now we're playing, and actually, if you can see over here, my guy is just falling down an endless pit right now. As you can see, Um, Notice something when we click stop on our Unity scene. If we click stop, if we go over here to our back to our script, we can see that our jump force turned back to 0. I set it to 500 earlier and now it's back to 0. And the reason for that, let me just change it back again. The reason for that is because when you click play, you can change variables and settings and stuff in your game. Like you can change the X coordinate and everything. But after you click stop, Unity actually resets all the variables and everything, and it resets it back to the settings that you had before you clicked play. So none of the settings get saved. So this is good to keep in mind, and you need to be sure to check when you change variables. You need to check to see if you're playing in the scene or not. Because let's say you do a bunch of work, like you update all these variables over here that you can update, and then you click stop, and then you just lost a bunch of progress. You forgot what all these numbers were, and yeah, you've lost a lot of progress. And this works with all the other components too. Like over here, if we take a look at the color component, where we can change the player's color, all over here, these are all variables. So let's say if I want to make it a dark red, all these numbers are changing, and this component is changing. And with that, if I click stop, it gets reset. So that's just something to keep in mind when you're just working on Unity in general. Alright, and with that, alright, but with that, we should be done with our player movement script. We're just completely done with it. If you have the number set to what you want, we are done. We can turn off, we can just close that. And one thing to make sure guys, that you are saving your game as we're going through this tutorial. To save, you go over here and click File and click Save here. Another way you can do it is click the hotkey next to the save. So for Windows, it's Control S, like with most applications. Control, and a way to see that you've made changes to a scene is that you'll see this little asterisk here. So since I have this asterisk here, I have unsaved changes. If I click Control S, those changes are now saved. All right, so we finished off with our player movement script, but before we move on to the next part of this tutorial, I like to go over a few things. First of which is if I click play, you might have noticed that if I go over here to the edge of a platform, my player tips over and falls down. And we didn't really program that in, it's just happening. And you might not want that for this sort of game, you might want that for your program. However, if you do not, um, this is how you get rid of it. So if we stop that, this has actually happened because of our rigid body 2D. It's just how Unity's 2D physics engine works. If a object is at the end of another object, it tips over. And actually, you can see that when you click play over here, we tip over, you can see that our z-axis is going crazy, and it stops after it hits the ground. That's because our z-axis is moving around like crazy. If I move it manually like this, you can see it's moving slightly back and forth. And to fix this, we need to go over to our rigid body 2D component and over down here constraints. If we open up this, you can see freeze position and freeze rotation. On the position, it shows X and Y, and on the rotation, it only shows the Z. And this is because uh, these are the three axes that the Unity 2D physics engines mess with. It, and the reason for that is because messing with the 3D flips the character around like so, and moving the character up and down. moving left and right with the X and Y. And those are really the only three things that you need to mess with in Unity 2D. And so to fix this situation of the player rotating around and everything, you just need to click on this freeze rotation, and now you can see even if I stand on the very edge of this platform, my player will not tip over. And sometimes you don't want that for your game, and sometimes, but if you do, this is how you do it. So let's click stop, and actually, I was playing, so that didn't save. So now I gotta re-click, recheck that Z, and just close it, and that should be good. Now the second thing I want to go over is actually saving. For the most part of this workshop tutorial, we've been messing around with our Unity scene, but we haven't really been saving, which is a bad thing because you want to save frequently while you're working on the project with anything really. So if we to save, we want to click on File, and then we over here we want to click on the Save button, and you can also click on the hotkey Control S, which is what I usually do. This hotkey is usually the same for most programs. It's the same here for Unity, and this is also the same for Visual Studios. So actually, I can click Control S, and before I do, to know that your scene isn't saved, you can just look over here at Sample Scene. You can see a little asterisk over here, and you can also see an asterisk on the top of here, onto the top of the program. Now, if you see these two, that means your scene isn't saved, which is bad. So I'm going to click Control S, those two asterisks disappear, our game is saved. If something happens to Unity, everything will be fine. Probably. Alright, so for the next part of this tutorial, we're going to go over prefabs. And what prefabs are in Unity are they're basically saving game objects, saving the settings of game objects, saving their components, and so you can use them so you can copy them later and use them for like different scenes and stuff like that. So to get started, let's try and make a prefab for the player um, character. Alright, so bear with me, this might get a little complicated. So you just want to take the player and you want to grab it, hold it, and then just drag it over here down to your assets folder. And you do that, that makes a player prefab. And we're done here. If you want to make a platform prefab, take the platform, drag it down over here. Perfect. And that's basically how you use prefabs. Alright, so now that we have our prefabs, what do we do with them? So, basically prefabs are here for um, saving game objects in case, like, let's say your player gets accidentally deleted, um, and then you save it. No, oh no. Of course, if you're still on the scene, you can always click Control Z, with to undo it. To I think it's also on the file or edit over here somewhere. It's somewhere, but you can always undo your changes. But let's say you don't like. Let's say it's deleted, you exit out of Unity, you leave it for a week, and then you come back and it was like, oh, I need my player again. One thing prefabs are good for is that it's a saved game object, so you can just drag it in. And if we look over here, um, all its settings are the same. The color is the same. Um, its box collider is the same. Rigid body has the same constraints. It has the constraints on the Z, and player movements here with the same settings that we left off with. So that's good. And it's also useful if we want multiple platforms. So like let's say this platform's a prefab, these two aren't, because we turned this specific one into a prefab and we made these two before this platform was a prefab. So let's say what happens if we delete them, and we can actually, to make an easy way to make prefabs is to actually duplicate a prefab that will make more prefabs of like more copies of the same prefab. So just like how you can make duplicates of a game object. Now, what's interesting about prefabs is that these all share the same settings because they're all connected to the same game object. Now, so let's say if I have, right now these platforms are blue. I actually want to change that. If you want to edit a prefab, the best way to do it is to double click on this prefab, and you can see you're in like some weird blueprint sort of space. You're actually not in the scene, you're in this little space specifically for the prefab. And now if we click on it, it has the settings that we have for the prefab. And let's say I want to make this, yeah, sure, a little, no, the player's already green. Let's make it a darker purplish hue. President probably like that. Um, so now it's purple, and we can save this and exit out. I think it automatically saves. Yeah, so now we changed this file, this prefab file, to purple. All the copies of the prefabs turned purple too. Now let's say I maybe like I want most of the settings for this prefab, but I want this specific prefab to not be purple. I want it to be blue. We can actually change if you edit settings over here, and we can change it to blue. We we change this little guy to blue, and these other guys are still purple. So that's another thing. If you want a prefab to be different from the other prefabs, um, just like a minor change, you can do that. Now, let's say you want it to change it back, like you don't like this blue. Um, there's actually a little tab over here. Because it's a prefab, you get these little tabs. Like, let's say if I make a great another game object, those tabs weren't there before. Like this game object doesn't have those tabs. However, these prefabs do. So it has prefab, open, select, and overrides. The main thing we want to do here is click on override. If we click on here, we notice that it says there has been changes in the sprite render. We changed the color. And if we look over here, it has two buttons over here, revert and apply. And it also has a revert all and apply all down here. And basically what this is asking me is that their Unity is noticing, hey, you made changes to this color over here. This is different than all the other prefabs. Do you want to like change it back to how it was, purple, or do you want to make this the new make this setting for all the new all the prefabs? Have this be the new setting for all the prefabs, I meant to say. So let's say no, I like the previous purple better. And so we click revert, and now it's back to purple. But let's just say I change it back to the light blue color. Actually, let me try and make I like that light blue color. I forget what it was before, but I like that. And let's say I like this. I want everything else to be like this. I should have messed with a file, because that would have simply changed everything. But let's say I messed with this file individually, but I decide, oh, I want all of them to be like this now. And so we go over here, we click on Sprite Renderer, we can click Apply, or we can click Apply All to apply all these settings to all the prefabs. Click Apply All, and now all of them are just bright blue. Perfect. Alright, so that's about it for prefabs, but before we move on, you can see the all our prefabs are just kind of in our assets folder, which is this can clutter a bit, so to stay organized, I'm going to go over here and create a new folder. Just like how we created a new script folder for our script, we're going to make a prefabs folder for all our prefabs. Just to stay organized, and so you and all your other team members know what you're doing if you're working in a team. Alright, so now that we've done with prefabs, we're done with the player movement script. We made a little player. It's a little green block, and he can move around. What's next? Well, let's try and make this player a bit more like a player, because again, right now he's just a green block, just jumping around. So, for right now, I have an exercise for everyone. I want everyone to go onto Google and just like go to Google Images and look for a face they can put on into their Block Boy, like a little transparent PNG image that they feel like would go nice on this whatever color your block is. And you can even have separate body parts, like you can have eyes, you can have a mouth, you can have a little hat, and I'm gonna do that myself. So just pause the video, find your assets, and unpause, and we can go move on to the next part. Alright, so now you should have your assets that you want to put onto your little character. Like maybe you got your face, maybe you got a hat or something. Um, anyways, you should have your images now. Maybe they're in your downloads folder or in your desktop. Just make sure you know where the file's at. And we're now going to try and add them to Unity. So first off, over here, we're gonna create a new folder because we're gonna need to put the assets somewhere. And we're gonna make new folder. We're gonna call this art because this is where we're gonna keep our art. And let's right click again and let's click over here, import new asset. And right here, this is the directory towards Unity project. I actually have, this is where I'm keeping my assets. So over here, you can see I got a face and a hat. Gonna import those two, and now I got a face and a hat. Another way you can do this is if you move your Windows, if you move your Unity window to the side, you can actually get the images from like a file explorer or the desktop and drag them into the assets folder and just like drag it into this section area to the programs tab. That should also work. I'm not going to do that because that would reveal Streamlabs and I don't want to do that. But no, but regardless of the method of you do that you should have your assets now. And now we're just gonna try and mess with the character, try to make him look pretty. So I'm going to drag over him. Let's try and give him a face. And that face is too big. That's not good. And okay, so I have a way to fix this. Over here, we just need to mess with its scale. So we just need to make it smaller so it fits with the player's block, just like how we messed with the size of the platform. And actually, this is a good moment to go over the different tools over here on the toolbar that Unity provides. So over here we have this little hand tool. What this is just a moving around tool. You can't really interact with any game objects, but let's say you have a bunch of game objects on the screen and you don't want to touch any of them. You can just use this hand tool to move around. And then you have this arrow tool, which, as you've seen before, as this is one of the default tools, it lets you move the transform. This red arrow moves the X, this green arrow moves the Y, and this little blue box moves both. And moving from there, this is the rotate tool. This actually rotates the image that you're looking at. For Unity 2D, you're mostly going to work with this blue circle. This is going to mess with the Z-axis. Because if you mess with the x-axis, or this is the y-axis. If you mess with the y-axis and the x-axis, it looks kind of weird. Because basically, since we're in 2D, messing with these axes are kind of like flipping them around, like as you would with a coin. And if you want that, sure, go ahead. But I do not want that. So, in right now, even now, right now, you can see these numbers. They're slightly adjusted. So I'm gonna switch them back. And I don't know if Chloe went over this, but another way you can mess with these settings is you can actually mess with these numbers directly, or if you click on the X, the Y, or the Z for each respective categories, position, rotation, and scale, you can actually mess with where they're at. You can mess with their X position, you can mess with their X rotation. You might need to drag a lot for this one. and you can also mess with the X scale, so you make it big, or really small. So yeah, another tool is this scale tool, and this can make your face bigger or smaller, and same thing with the Y. And if you click this white box, you can make both bigger and smaller. Now, for some reason, even though we're in 2D, that also messes with the X axis, so be mindful of that. I'm going to switch that back to 1. Next over here is the rect tool, and I believe Chloe went over this one, where it's also a tool where you can like scale your little face and change it to how you want it to look. I believe, yeah, if you hold shift, it makes it so that the face scales um, percentage wise instead of just like moving around. It's relative to how its original size is. Slight, so yeah, the difference between this one, this rect tool, and this scale tool is that if you notice in the coordinates, um, you can actually see that the scale isn't just moving. The X and Y axis are also moving. That is because this rect tool is more interface friendly. It's more friendly to people who just want to move around the player how they please. While this tool, the scale tool, is more, I guess, number friendly. It only moves, if you click on the x-axis, it only moves the x-axis, and same thing with y, it only moves the y-axis. So keep that in mind for which tool you want to use, and you can see how different both of them look. And I believe this one is also a rotation tool. Oh, this one is a rotation combined with a transform tool. Um, I'm not too sure about this one. I mean, I haven't used this one too much, but hey, the more you know. All right. So another nifty thing about this is that this is actually these all have hotkeys to them. Over here, this hand is Q. This move tool is W, and if you can see on your keyboard, the next rotation tool is E. You can see that it just goes down the lane. Yeah, it just goes down the line on the keyboard. So Q, W, E, R, T, Y, U. Um, except for U. I don't know. Right, and so with that, my face is utterly quite a mess. So I'm just going to reset all its settings back to its original. And with that, I want everyone to, actually, I'm also gonna drag in the hat. That hat is bigger than the face. And right now I'm just going to mess with everything and try to get my player to look like, to have this face and have this hat. Right, so I have everything just about done with my player. The face is there, the hat is there, except if you notice, the hat is kind of behind the player. And maybe some of you will come across this problem. And the reason why this happens is because I've just been dragging these guys in here. Unity doesn't really know, there hasn't been like a distinct factor to like what goes on top of what. Like, because Unity doesn't know this is a hat. Um, as far as Unity is concerned, this is a PNG file. These are all PNG files. So, and because of that, Unity doesn't know what to do with them. Um, However, Unity does give us the tools to change it up, so we can put this hat in front. And they do that with the component system, actually. If you look over here at the sprite renderer, this hat is only here because of the sprite renderer. Like if I turn it off, the hat's gone. If I put it back on, the PNG, like the game object is still here, but the PNG is gone, and now it's back. So if we use that information, we can probably gather that to mess with where this PNG is on in its order, we can go through the list of components here, and what do you know? A sorting layer and the order in the layer. So if you look over here at the hat, at the face, and at the player, all of these are at the default sorting layer, and their order in the layer is at 0. So if anyone has any experience with like photo editing software like Photoshop or something, you can probably get an idea of how to fix this problem. You want this hat to be on top of the player, and so to fix that, you want its order in layer to be higher than the player. So now that it's higher than the player, it goes on top of the player, and everything is now spiffy. Okay, now that I have my player the way he wants it, the way, well, the way I want it, um, he doesn't get to decide, he's just a PNG. I'm just gonna save, and let's actually just test this out. Alright, lovely. Face is gone, block is now a block again. If I jump, I can't get it back. Alright, so why does that happen? Well, that's mostly because we didn't prompt anything to say, hey, Unity, I want this face to be on this block, and I want this hat to stay on this block also. Alright, so to fix this problem, what we want to do is click on the face, and we want to take it and drag it over here, and make sure it highlights onto the player, and let go. And then now you can see the face is indented inside the player, and there's actually a little drag down that we can close that closes the face, and we can open it back again, and yeah, now we have this sort of setup. And if we want, we can do the same with the hat. Now that's in there, you can save that, and if we click play, hey, there we go, now they're sticking in place. Alright, so what just happened was that we made this face and this hat child objects of the player. And basically what a child object is, for the most part, in terms of transform, is that if we make this face a child object of a player, um, basically, um, it's like sticking this face game object onto the player game object. So now whenever we're telling Unity whenever the player moves, we want the face to move, and if whenever the hat moves, whenever the player moves, we also want the hat to move. And if you can see, if you notice when dragging onto these game objects onto the player, their transfer kind of changed. If you can, so let's see what happens if I put this to 0, 0. And if you can see, this hat isn't centered at normal 0, 0. It's actually centered onto the player. Because the child object, now its location, its position, its rotation, and I believe its scale is real. Actually, I'm not sure about the scale, but its position and rotation is in relation with the player. So if you move over here, this doesn't mean where it is on the map. This actually means it is negative 0.53 degrees, or it's negative 0.53 on the x-axis away from the player, and it's 1.05 above the player. And yeah, so let me just switch that back over here. Okay, actually, before we move on, if we click on the player, we can see that our prefabs aren't saved yet, so um, make sure to always keep your prefabs updated, because if you don't keep them updated for a long time, um, your prefabs can get messed up, especially if you have multiple scenes. So I'm going to go over here, apply all, because I want all these saves changed, and let's go on with the video. Alright, so now we got a little spiffy guy over here, and we can click play. He sticks around, he moves, we can move it around, but you can see as we move left to right, the player doesn't turn around. He doesn't look the other way. He just kind of backsteps. He just keeps backstepping all the way off the screen. All right, so our player isn't flipping, and yeah, to fix it, what we're going to do is we're going to add animations to our project. And what I mean animations, we're not gonna go and make some arts for this guy. Actually doing animations in Unity is more technical, and we don't really need to add any more art to the game. We can do it with the assets we have right now, the face and the hat. All right, to get started, we're actually gonna go over here to our windows, and we're gonna add a new window to our scene. Actually, two, I believe. So we're gonna go down here to animation, and we're gonna add the animation window, and we're gonna add the animator window, both of these. So we're gonna click on that, and click on that, and for both of these, I'm gonna put them down here. You can put them to where you think it best fit, but and for me, that would be down here. Alright, from here, we want to go to our player, and we actually want to add a component, and there is a thing called an animator over here, and we actually want to add that component to the player. Alright, and from here, we want to go to our project. This is a lot, but please bear with me. We're gonna add a new folder, and this folder is gonna hold our animation stuff. So we're gonna call it animations, and we're gonna open it up. And now we're gonna create, if we go, I believe down over here to this little animation section, we're gonna create an animator controller, and then we're gonna name this player animations, or player animator, because this is an animator controller. And if you saw when you look at the animator component, it is asking for a controller. So what we want to do is we want to add this newly made controller onto our component. So let's take this and we're going to drag it into here. And the component's going to accept that. And now on we have an animator component on our player. And what that allows us to do is create animations. Alright, so now when we click on the player and we go to the animator, we can see that um, there's stuff for us to mess with. And basically this whole setup is the player's animation system. And the reason why the player has one is because we added an animator controller to him. So let's see here. What we want to do is we want to add an animation to the player. And let's say we want this to be, we want this animation for when the player turns around. We can add a bunch of different animations, like we can have an animation for when he's idling, when he's not moving, when he's moving, so when he's rocking around. But for now, we're just going to keep it simple, and we want to make it so the player just turns around when we want it to. Okay, and so for this, we want to name this flip. Flip, or actually, let's name this turnaround, because I want to name something else flip later. And if you can see here, it doesn't have a motion, and so what we want to do is add a motion to this little guy. And we can do that by going back to our project, click create, and click. There's no motion option here in this little animation category, which is which is, and to fix that, I mean, what it's actually asking for is it's asking for an animation. So let's create animation, and we're gonna create an animation called flick. And we're gonna go over to the animator. Oh, this was click on turn around, go back to project, take our flip, drag it over here, and as you can see, the animation goes into the animator. And now we have that. And actually, I may have overlooked this a little bit, but if we look at the oversight of what we want the player to do, we don't just want the player to just turn around, because even an animation of doing nothing is an animation. So if this is the only animation it knows, the player is just going to constantly turn around. But we want it to face forward and to face backward, not just and turn around is going to be the one in between that's going to go to and for back and forth with. So we're going to actually add two more animations. We're going to create a state, empty, and for this one, I'm going to name facing forward. And I'm going to add another one, another state. This one's empty. And this one's called facing backward. And if you look closely over here, you can see there's this green box that made an arrow to turn around as soon as turnaround was made. This is the entry node, and basically this, when the game starts, th this will activate, entry will activate, and it will go from entry to this arrow, and it will go straight to turnaround. And we don't really want that. We want the player to face forward instead. So we want to switch this to face forward. And so what you want to do is instead click on set state machine to default state, and you want to put that onto the facing forward. And what that does, it sets that orange arrow to facing forward, so on entry it will go to facing forward. And so now it will face forward. Um, However, we also want it to face backwards. And from facing forward, how this will transition is that when it's facing forward and we want it to face backwards, it will go to facing forward, to turn around, and then to facing backwards. However, now we can go from facing forward to turn around to go facing backwards. Um, However, what happens if we want it to from facing backwards back to facing forwards? Um, we're gonna actually not use turnaround because turnaround goes from facing forward um, to facing backwards. So in a sense, this animation is gonna go from facing forward to facing back. We want it to go from facing back to facing forward. So we want a different animation. So we're gonna make a new one. We're gonna make four animations here. And this one, I'm gonna type turn front because we're gonna have two turn animations. I'm going to name this one turn front, and I'm going to rename this one turn back. And from facing backwards, we're going to make a transition to facing front, back to facing forward. Okay, so now we have this set up. However, we don't really have any conditions for when from you're facing forward to face backwards, and then when you're facing backwards to face forward. So let's add some. Over here on this section of the animator tab, you have this little section called parameters. And what we want to do is we want to add some parameters. And parameters here are just basically just variables that the animator engine is going to check to see yeah, they're going to check to see if they update or not. And over here, if you're familiar with coding, you know what these four types of variables are. Basically, a float is let's start with integer. An integer is a number, a float is a number with decimal, a boolean is yes or no, on or off sort of switch, and a trigger, this is actually new, um, is kind of just a boolean, except when it turns on, it immediately turns itself back off. So it's like pulling the trigger on a button, pulling the trigger on the gun, or pressing a button or something like that. So for these sort of situations, let's say, um, I'm going to go with a boolean. So in this case, I'm going to have one boolean, and I'm going to name this boolean facing forward. Okay, so now I'm going to name it facing forward. I'm going to have the first FB lowercase, the next FB uppercase. This is called camel casing. It's just um, a way to name your variables that I learned as a programmer. Alright, so from here, we're going to click on this arrow. If you click on this arrow, you can see a bunch of stuff. But the main thing I want you to focus on is I want you to focus on this conditions. And what we can do here on this conditions, which right now is empty, we can click on this plus button and you can see, hey, it added one of our parameters, our only parameter, facing forward. So what this is going to do is it is going to check to see if our parameter is true. If this condition is true, it will activate this arrow. So when facing forward is true, which is in this case we actually want it to be false, when facing forward is false, it will turn around and face backwards. And in a sense, so now we have this for this arrow. Um, For this arrow, we don't really want much because we want it to face forward, turn around, and then face backwards. So this arrow just needs to activate when turn back is done, which it does that automatically. How do we know this? From this arrow, we see has exit time is checked. That means that um, it has to wait a certain amount of seconds before it can go to facing backwards. And usually, it by default, it has enough time to play the animation it is playing. However, for here, for facing backwards, we do want to have a condition for this arrow to turn to facing forward. We want to check it to see if facing forward becomes true. And so it goes to facing forward. If the player is if facing forward is true, we actually don't have any code for this currently. Basically, this is just a parameter. It, it's named facing forward, but really it's not really checking for anything right now. It is just a condition. Later, we will go back to scripting, and there is a way to actually change this condition so it aligns with what we want to check for. But for now, this is done. Except for the fact that we don't really have any animations yet. And even when we do, for this flip animation, um, we don't have, we didn't really write anything for this motion, for this animation. So let's go do that right now. Let's add motions and drag them in. And first off, I'm gonna rename this one, flip back. And I'm gonna make another one called flip forward. And yeah, I'm just gonna do this real quick. I'm gonna cut, and by the time I'm done, all these will be made. da 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 ba da 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 dum ba dum bum bum da da da. Oh man, this is getting really weird. That's not good. My mouse is getting janky. Okay, that's better. Excuse me. Alright, now we're back. I created four animations. I actually added on to the name I renamed earlier. I have flip the front, flip the back, face front, and face back, and I've added them all to the respective nodes, I believe is what the animator calls them. So now we have our nodes, but they're completely empty. We didn't write anything, we didn't do anything to them, so the player is just gonna stand here, just like as it does before. Actually, if we can check, click save, go to game, click play, it does absolutely nothing. But if you can see here, the only arrow that does work is entry to facing forward. And if you can see, facing forward plays. If you mess with it while the game is running, stuff happens, but that won't, you don't need to worry about that because that can't happen when you're actually playing the game. Alright, so let's stop it here. And let's actually add something to these animations. And to do that, you can go to the animation tab over here. And if you can see here, everything is grayed out. You can't click on anything. Everything is disabled, basically. And the reason for that is that right now it's looking for an animator. And it's looking at through whatever you're inspecting. So right now we're inspecting a node from the animator, and that node doesn't have an animator because it's not a game object. So it's not doing anything. If we click on the platform, platform doesn't have an animator, but we can we can add, it's asking to add one, or specifically to add a random animation clip, because I believe you can add a specific animation. Let me just type this out. Yeah, you can add a animation straight to the to a game object instead of adding an animator. But right now we have the player who does have an animator with animations, and if you can see here now everything is lights up. And if we click down on this drop down, we can see all the animations attached to the animator. And so let's begin editing these animations. Let's start making animations. And the way we do that is because we're not working with any art, we're just working with our game object. There's actually a way to do this. And the way to do it is there is this record button, and that will do is if we move around the game object, it will record changes that we make. So let's say I have the player at this position, and this is actually like a time scale. I believe this one here is 1 second. I might be wrong. And if we move it forward, you can see it adds these little keys. And now we can see if we drag it back and forth, we can see from this key to that key, it'll go from its starting position and move over to the ending position. And if we want to undo that, we can just grab, like let's say we want to undo any changes we do to the Y position. We just click on the Y and then we can just delete it, and we can delete here too. And if we want to delete everything, we can click everything here, delete it, click everything here, delete it. And so with that, we can start making animations. One thing to note, however, um, when you're making animations, you actually what I just did there, you don't want to do. You don't want to register the player's transform, specifically this game object player's transform into the animation, because what that does, it creates an animation where it constantly changes, or at least sets the transform to whatever this position is, and that takes that takes command over our movement script actually. So it will every frame it will set the player's position to whatever this position is if we kept this animation here. If we just left it like this and called it a day, which is something that we don't want, because if it's this, then we cannot move the player. If we try to move right, then it will maybe move like very slightly to the right, and then it will change to whatever this number is currently. So we don't want that to happen, so we click undo, make sure that the player's transform isn't on there, but what we can do, because they're not affected by the script, is mess with the child object. So we can mess with the face and mess with the hat. And for this specific animation, this is facing front. We don't want anything too much. We just want the face to be there and we want the hat to be there. So we want it to keep its original position as it is right now, but we want to add them to the list. So we can say that it's part of the animation. And one way to do that is to Well, one way to do that, let's do it for the face first, is that we can move it slightly. First you want to click record and then move it slightly, and that records its position. And if we click the undo, oh no, not the undo button. And then after we get its position, we just move it back in place, get a like generally move it back to where you had it before, and that will record its animation. And because you didn't select a different frame or timestamp, it will just stay like this. It will not move around. And same thing with the hat. And actually for the hat, I'm going to do something else. I'm going to add a property and I'm going to click on transform. Actually, this transform is actually the player's transform, so I don't want to do that. I want to go to hat and add its transform. So I want to add specifically its position. So now we have hat position and face position. So we have those, and that's all we really want for the facing forward animation, really. And if we click play, it's just going to stand there, which is exactly what we want when we want the player to face front. If you want, you can add a little nifty animation, and we're going to learn how to do that when we go over to here, when we click on the flip to back animation, which is something we want to do. Which was something we actually want an animation for. So we have created freedom for this because these are animations and these are your own specific block boys. So for mine, I'm gonna click record. Well, first I'm gonna add the hat, transform, position, or the face, and then the hat. And then I'm gonna have it here. And then actually, if you add it, it actually assumes that you're gonna change it around. So it changes the position, and which is nice because after a second, or through the duration of a second, um, I would like to turn this face around. The easiest way to do that is to just Move it over here. And if you can see, this face is still kind of facing towards the front direction. Um, an easy way to change that is over here in the sprite render, there is a property called flip. And if you do that over the x-axis, that flips the art and makes it turn around to the other direction. And if you can see over here, the animator registers that change. So if we look over here, it goes from being in front to being in the back. And this could be fine, but maybe I'd want to make this change more instantaneous. Maybe I don't want the slide and then flip. And if that's the case, I can always um, take these nodes and bring them in closer. So now it's more instantaneous. Oh, well, that's not close enough. Let's scroll down in. There's a frame between that, so now, yeah, it's gonna go instantaneous from front to back. And I'm going to do the same with the hat. I'm gonna take this hat, and I'm gonna move it over, well, first I'm gonna go over here, gonna move it over here, and I'm gonna flip it on the x-axis. So now it's a bit off, but now the player is technically flipped. And actually, let me bring this down. I believe that looks about right. And let's say I want to do something fancy. Okay, let's do something fancy with the okay, so the movement is gonna mess with the position. But however, well, the rotation and technically the transform are safe to mess with. So I'm gonna mess with the rotation. So I recorded the rotation over here. And what I'm gonna do is I want over for the duration of a second. So I'm gonna go over here to the 1 second area. I am going to actually flip, well, wrong side, I think. No, wrong object. Lovely. I am going to flip. I'm going to flip the object. And as you can see here, that actually flipped everything, including the hat and the eyes. So actually, I don't believe I need this one. Let's see what happens if I delete this. Oh, okay. Yeah, I don't need to do I didn't need to do all the other stuff because Flip did it for me. Perfect. Lovely. Okay, so now that's all done. And if you can see, this eye got a little messed up. I believe that we can fix that by taking the face and end recording because all of this is recording's probably going to catch this and say it's like, oh, this is a temporary change that you want to do for this animation. No, this is something permanent. I'm just going to add the order layer to the front so it's always in front of the player. There we go. And actually, we didn't really need to mess with the face position, to mess with the flip X, and to mess with the hat's position, the face X. And really, all we need to do is just flip it around. And I feel like that is a clean turnaround animation. And I'm going to do the same with the flip the front, and I'm gonna add a face back, and I'm gonna have it generally the same. If you want to add some fancy animations to your characters, you can do so, and I'm gonna cut to when I finish with these animations. Alright, so now I got all of my animations up and running. We have face back, so that's just the player turning around, and we have flip, the front, and we have flipped back, and we have face front. So now with that, oh, whoops, I think he just went there. There we go. Now, um, now that we have all that set, we have all our animation set and in place, and we have all these arrows set up. The only thing left to do now is to mess with this parameter. And the only way to do that is actually with um, the Unity script. So we're going to go back to our player movement, but just to make sure everything works, we can actually test out our script in the inspector. So right now he's facing front, and let's say we want him to move back. Now he's going to turn back, and now he's moving back. And if we want to make him move front again, go to the front again, he turns around and goes front. Perfect. Okay, I believe if I'm looking at that animation correctly, that might be too slow. Um, so I'm just gonna speed it up a little bit, maybe go to 15 and 15, play it again, and we can see, yeah. Alright, so that's going now. Okay, so now we're gonna edit our Unity script, open up Visual Studios. Okay, now we have our player movement script. So last we left off, we added jump force, and now we're going to add um, our parameter from Unity. So actually, let me go over and see in the script. So right now we have on our animator facing forward, and so we're gonna go over from there to here. First things first, we want to mess with our animator component. So what we're gonna do is we're gonna add it to our script. So we're gonna write private animator, and I'm just gonna name this anim, and we're gonna mess with this animator the same way that we mess with this, kind of the same way like we mess with our rigid body 2D. So over at start, we want to find the animator component. So anim is equal to get component animator. All right, there. So we have that. Save our script real quick. And then over at the update, so how this is going to work is right now we have our, yeah, right now we have our transform moving left and right depending on what our input is. So, what we can do is we can actually use this input not only to use input that can access horizontal, which is our left and right keys, we can actually use this to see if the player is moving left or right by depending which one by checking which one is down. So what we can do is we can create an if statement. This can be before or after the jump statement. It doesn't matter too much. So if input dot get access, and if we check raw, um, the difference between raw and regular access is, if you can read here, it has no smoothing filtering applied. And what that means is that for stuff like, this is more specific to stuff like joystick, like for instance, you can have a joystick be half tilted or fully tilted, or anywhere between not tilted and fully tilted. Now, what this script does is it checks to see, it doesn't consider if it doesn't consider that. So if like a joystick is slightly tilted, the script will consider it to be fully tilted. So if like horizontal axis is equal to zero point 0.1, this get raw axis raw will change that to a full 1 or a full negative 1. As if we remember, get axis gets so either a 1 or a negative 1. This shouldn't matter too much since we're working with keys and keys don't have an in between. But it's good. But if you were working with controllers, this would be helpful. So if input get access raw, so this is either going to be a 1 or a negative 1. So we actually want to create a statement here. We want to check to see if this is equal to 1. Well, let's first see the check to see if this statement is equal to 1. And that means that the right arrow key, this statement would mean if the would check to see if the right arrow key is pressed. So we can open up our brackets, and then if this is true, which means the player's moving to the right, we can make the player face forward. So what we can do is type in anim dot, and if you can already see here, it highlights set bool. So what we can do is we can set the bool parameter that we have, um, and if you look over here, we have ID and value. If we click on this, we have a different layout where we can check for a name and value, and we want to do that. So what we want to do is we want to type in a string, which is going to be the name of the variable that we made, and we want to set its value. So I'm just going to leave that blank for now, and then we want the value, oh, whoops, we want the value to be set to true. So we're going to have that at true. And actually, I'm going to go over here just to triple check to see our variable name is facing forward, lowercase f, capital I is f for the second f. So we're going to go back to the script. So I'm going to type in facing forward, exactly like how it is in the animator. And so the animator will check to see if this parameter exists. If it does, then it will set it to true. Don't mind my phone. Apologies for that. So now that we have this set up, we're gonna check for the opposite. And we're gonna check to input get axis raw horizontal. We're just gonna type in the same thing. Except this time we're going to check to see if it's negative 1. So if the left arrow key is down. And this will check to see if the player is facing to the left. So then if it is, we want, or if the player is moving left. So if it is, we want facing forward column to be false. And with that, it will make the player turn left. And for that we can save. And that's actually all the code we need to get the animator up and running. So let's go back to Unity, and it's gonna update all the scripts. So now that they're updated, we should be able to mess with the animations of the player. So if I click left, it turns to the left, and then there we go. And if it turns right, it goes to the right. Turns left, goes to the left. And if you see before, it was a little buggy. Um, with how it is, and if you can see the reason for that is because if I move left and right really quick, I'm actually going too fast for the animator, because it's waiting for facing forward and facing backward to finish up. And actually, so an easy way to fix that is to go over here, and if we remember about the exit time, we can actually uncheck that so it doesn't need to wait for the full second or so that facing forward is on, and we can do the same for facing backwards. So if we can save that and test it out, we should be able to go back and forth like crazy, except um, except now it's waiting for a turn back and front to finish up. So a way to fix that is if we go over here, we can't change the exit time. I mean, it has exit time over here. We can't uncheck mark these two because if we do, it's just gonna go directly from turn back into facing forward, which is what we don't want. But what we can do is if you look over here, we can actually decrease the amount of time it has before it goes into the next animation. Let's say maybe 106%. Let's see. And really this animation works as is. And right now I'm just fine tuning my specific animation to the way I want it. So that makes it turn back and forth really faster, much faster. And let's see if we decrease this a little bit more. Let's see what happens. Yeah, as you can see, it goes back and forth still, but not as fast as maybe I like it. However, it does work for the most case. And now it would just be now for me it would just be fine tuning everything, looking at maybe these um these variables and messing them around or messing with this around to just fine tune everything. However, um it is technically done, and that concludes the animation part of this tutorial. And if I that also concludes the Unity Crash Course itself. Alright, now that you completed this tutorial, all of you guys here should have enough knowledge to be able to tackle your own game using Unity. However, you might be wondering, where do I go from here? Like, we went over very little with Unity, technically, and you might have questions to how to make your own specific game. Like, if you're making a platform, how do you get the player to stop jumping infinitely? Which is something we know about that happens with this tutorial. Or even if you weren't making a platform, how do you even start from that? Well, from here, if you have any questions on how to make your own game, your own specific project, I'd like to point you to something called the internet. I don't mean to be brash, but um, it's true. Googling answers is a big part of learning game development. It's how I and a lot of other officers learned how to make games. There are a ton of resources out there that can help you. And now that you know the basics of Unity, hopefully that will help you get a sense of what kind of questions you want to look for or what questions you want to know to help try and make your game. For instance, there's a YouTube channel called Brackies. I'll put the link in the description. It's a channel made specifically for making that houses a lot of tutorials for Unity, and you'll probably take a look at a few of his tutorials in the future, whether intentionally or not. He has a lot of tutorials. And something for our club members. If you have any questions, you can also go to our VDDA Discord and ask for help. You can ask for questions in our questions channel, or if you have a specific discipline question, like if you're a programmer or an artist, you can ask those questions in the the specific disciplines channel, depending on the question. If you want, you can also message me for your questions, or you can message Chloe, or you can message on any of the other officers if you have any questions and you really cannot find it on the internet. Um, or if you're more comfortable with that than asking on the Discord server. But with that, this concludes our Unity crash course. We hope that this video was helpful on your journey to become a game developer, and we wish you good luck on your next project.